So far, our gateway only does one thing. It chats. This episode, we add a second skill, one that quietly powers search, recommendations, and every RAG system you have ever used, embeddings. An embedding turns a piece of text into a list of numbers that captures its meaning. And once text is numbers, you can measure how close two ideas are. Let's build it.
So what actually is an embedding? You hand the model some text, and it hands back a vector, a fixed-length list of numbers, 768 of them in our case. Think of that vector as a coordinate, a single point in space. And here is the magic. The model places text that means similar things close together and text that mean different things far apart. The words do not have to match, only the meaning. I'm locked out of my account, and how do I reset my password? Share no words at all, yet they land right next to each other. So how do we measure how close two vectors are? With cosine similarity. Picture each embedding as an arrow from the origin. Cosine similarity measures how much two arrows point the same way. 1.0 means the same direction, the same meaning. Around 0 means unrelated. It is just a dot product divided by the two lengths, 3 lines of plain Python, no library required. Embed a question in a pile of documents. Score each one. Sort by the score, and the top result is your best match. That ranking, find the nearest vectors, is the engine inside every RAG pipeline.
So in our gateway, we will add the second most important API that is available on OpenAI SDK or LiteLLM, that is called embedding. And it's written like this. It's the second important one after the chat completion. So we import it from LiteLLM and we'll use it in our code. The other things is like previous code, so no changes. We just add one other class for the data that we need to use for our embeddings. We need again a model like the chat request. We have an input that will be a str or list of strings and the dimensions, since some models will allow you to choose shorter vectors. And the goal here is to just convert our strings to a vector, so we can run some mathematical computations there. We add a new endpoint here called embeddings that will accept requests from a user that will check if he is or she is authenticated. And then we have again our enforce limits functions to check the rate limits and budget of that user. We will call the embedding method with the model, with the input that will be a string or list of strings, and the dimensions if we have defined it. We will track again the usage for that. We have only input tokens or prompts. There will be no completion or generation here. And we just give back the response as a dictionary to our client. So let's run it. So our gateway is up, and let's check our client. So here we will just use some examples to call our gateway for an embedding. It means we have some strings. We want to convert it to vectors, and then we will use a semantic search. We will see how it works. It's a simple cosine similarity. We will write everything here to get a better understanding of what those things mean. So we have our gateway. We have our model here. That's Gemini embedding. And we define the dimensions as 768. So it's smaller, cheaper, and it's enough for our learning purpose. We define our client, and then we have here the function of embed that get the text and will give us the list of vectors or embedded text. Then we have the cosine. For simplicity, if you can write it with numpy or anything else, it's just a dot product between two vectors that are already two texts that are already embedded and are converted to numbers. And they will show the similarity. If it's 1, they are 100% the same meaning, and if it's 0, it means they are completely unrelated in meaning. So I would say let's run it and see what we So let's go through the results and then see. So what is an embedding? So assume we have a text here, a list of just that has just one member, that is this text, and we want to embed it. It means we want to convert it to a vector. So we convert it as we wrote the length of the vector for this part of the string is 768, and you can see the first numbers here inside our list of numbers. Then let's do a quick semantic search. We have a query or question. I'm logged out of my account, and then assume we have 3 simple documents. How do I reset my password, the cat, and our return policy. And then we want to find the nearest docs in the meaning to our query. First, we need to embed everything. So what we do is here is we embed both the queries and the documents in one run, and then we ranked them against each other. The query against each document, and then sort it to get the best ranked document. Here we see the results. Semantic search for I'm logged out of my account, and here is the nearest one. How do I reset my password? This is the best match. The note is that it shares, if you see, it shares no words with the query. Match is only on the meaning, not keywords.
And that is embeddings. Text becomes a vector. Similar meanings sit close, and cosine similarity ranks them. Semantic search in about a dozen lines. Next episode, we put it to work. Retrieval Augmented Generation, RAG, where we use this exact search to feed an LLM your own documents, and finally chat with them. If this helped, give it a like and subscribe so you don't miss it. The code is in the description. See you there.